Welcome to ercTipsKnowLogy. In this video, we will be continuing to do a project about using Arduino Uno in Tinkercad.com. So let's start. Let's click on Designs and then click on New Circuit. And then after that, you will be seeing the screen for the Tinkercad.com. And of course, we will be using Arduino Uno. So in Tinkercad, there's a ready-made Arduino simple projects by simply clicking on the components and then Arduino. And for example, if you click on the breadboard, you will see this. It has a ready-made breadboard wherein the negative rows of the breadboard is connected to the other negative rows of the breadboard here at the top. And the positive here is also connected to the positive at the top of the breadboard. Now at the bottom, you will notice that the positive of the breadboard is connected to the 5 volts of the Arduino Uno, and the negative is wire, which is black wire, is connected to one of the grounds on the power side of the Arduino Uno. So this is one example of making a project in Arduino where you want to use a breadboard. Now what I'll do is I'll show you another one. When you click the blink project, then what will happen is that you will be presented with a ready-made blink project here, and when you run it, it will really be running. So as you can see, the LED is already blinking, and it has a connected resistor here, which is 220 ohms to pin 13 and the ground. And this is also blinking simultaneously with the built-in LED on your Arduino. Now you can stop the simulation and you can go to the code, block, text, and you will notice that the program is already here, which is about blinking the built-in LED. But if you will look at the other video that I have done before, you will notice that we did not use LED built-in. Instead, I use 13 to represent the built-in LED. Now, if you want, you can also delete all of this again, and we can go on the fade. When you click fade, you will see here the fade project, and when you go to the code and blocks and text, you will see the complete program with some comments here what the fade program is all about. And this example will show you how to fade an LED on pin number 9 using the analog write function. So you will see here that the cathode or the anode of the diode is connected to digital pin number 9, while the cathode is connected to digital pin of the Arduino Uno, which is represented by the ground or GND. Now the code is already there, and if you will just read what's written here, the analog write function uses PWM. So if you want to change the pin that you're using, be sure to use another PWM capable pin. On most Arduino, the PWM pins are identified with a tilde sign, like tilde 3, tilde 5, tilde 6, tilde 9, tilde 10, and tilde 11. So these are the PWM pins. The digital number 3, digital number 5, digital 6, digital 9, 10, and 11, or all those with the tilde symbol. Now, you will see here also that there is a variable brightness, which is initialized to 0. And in the setup, we declared a digital pin number 9, or the one that uses PWM, as an output. And also the loop, in the loop, we have here a for loop where the brightness value will be repeating from 0 to 255. And it will increase not by 1, but it will be increasing by 5. So the brightness will start from 0 and then 5, 10, 15, 20, 25, or it will increase by 5 up to 255. And it will be doing this line numbers 25 to 26. So the analog write will make the LED to turn on, but it will not simply turn on, but the power or the brightness of the LED will depend on the value of the brightness. In other words, the LED will be starting from 0 brightness, and then its brightness will become 5, and then 10, 15, so that the LED, it's like increasing its brightness from no light up to the maximum brightness that it can have, and there will be a delay of 30 milliseconds. And then when it reaches the brightest brightness, which is having a value of 255, it will go down to 0, and that will be done by this code on line number 28, where the brightness will start from 255 and then it will be going down up to 0, and the brightness value of 255 will be subtracted with 5. So the 255 will be 250, 255, 250, 245, 240. In other words, it will decrease by 5, or the brightness of the LED will be decreasing by 5 until such time that it reaches 0 or no more light will be there. And there's a delay of 30 milliseconds. That's why when you run the program, you will notice that the brightness is increasing, and then when it reaches the brightest brightness, then it will be going down to no light. So from no light to the brightest, and from the brightest to no light. Actually, you can also change the program here, as in you can change the delay. You can make the delay 100 milliseconds to make its brightness changes be slower than what you see now. So if I do that, and if we also change the resistor to 100 ohms, most probably it will be brighter than what you have seen before. So let's start the simulation, and this is what will happen. As you can see, it's becoming brighter and brighter, but not as fast as before. And it's losing its brightness again, and not as fast as 30 milliseconds. So this is another example. And of course, if you want to use breadboard, you may do so, but here we did not use any breadboard. So let's stop the simulation and delete this example. Okay, now let's go ahead with the button. When you click button here and drag it on your screen, you will see that it has a button or a push button switch here, and the terminal 1B is connected to number 2, digital 2. Terminal 2B is not connected anywhere, and then the terminal 1A is connected to the ground. But before that, there's a resistor here which has a value of 10 kilo ohms. And the terminal 2A is connected to 5 volts. Now, if we open this, if you run this code or program for this button example, you will see that when I click or push the push button switch, the built-in LED is turning on. So if you don't notice it, look at the letter L here for the built-in LED. When I push the button, it will be turning on. Now let's look at the code. Let's stop this and let's look at the code by clicking on the blocks and the text. And you will see here the program where there is a variable button state which is set to 0. And then we use pin mode 2 digital 2 will be input because it's a switch. uh, if you will look at the digital 2, it is connected to our push button. That's why you will see here that pin mode 2 is now an input because it's a switch. And then the pin mode LED built-in, as in the previous video, LED built-in refers to this one, the LED which has a letter L, or you can also say that it's the digital pin 13, will be an output pin because it will be for the LED. Next, we have the button state variable was assigned with the value of the push button switch. So the digital read is a command or a function that will read the value of the switch. Of course, if you push the switch, it will become 1 or high. And if you don't push the switch or the push button, it will be 0. That's why when whatever you do with the switch, you're not touching it, then the value of the button state will be 0. And when you push the push button switch, it will become 1 now or high. Now, in line 38, we are checking or validating if the button state will be equal to high, meaning you push the push button switch. So if you do so, then the LED or the digital pin 13 will become high, which is actually the where the LED is connected. So if you push the push button, the LED will turn on. That's what's happening there. Now, if you don't push the push button switch, then the LED will not turn on. And that will be the responsibility of this command. Else, when the push button was not pushed, then the LED on digital 13 or the built-in LED will become off. That's it. And there's just a little delay placed here so that there will be a little bit of time to between the pushing of the button and when you push the button, there's a slight delay of 10 to process the validation. So this is the example. Again, let's start the simulation. And again, when you click the push button, then the LED here will be turning on. Look at that. Okay, and then when I don't push the button, then it will be off. So that's the another built-in example here, and you can use this as a pattern for your other programs later on or your project. Now let me delete this and let's look on other examples. Let's try to use the buzzer. So here there's a tone melody, and this is useful if you have some sort of an alarm system. So let's do this. So this is the Piezo or Piezo buzzer, and it's connected on the digital 8 for the positive, and on the negative of the buzzer or the speaker, it's connected to the ground. That's it. And when you run the code or the project, it will make a sound. Again, let's run the project. So that's the sound that will be produced. But let's look at the code so that you will understand this. So line number 1 to line number 17 is simply a comment. And it's just telling us that this is called melody and it plays a melody. But it's not really necessary to do this. Now, for example, here, this also says the creator and when was it created, and this is for public consumption. You can use this, and there's also a website where you can see the tutorial for that. That's it. Now you can cancel this message or comment, and then it's defining some notes here. Of course, if you don't have any musical knowledge, then you will never understand this really. But for notes, there is a certain note, and we call it C4 or In another term is do, like do, re, mi, fa, sol, la, si, do, and this is the letter C, D, E, F, G, A, B, C in the chords. Now, this has a certain frequency of 262 or a value 262. And then there's another note here which is G or sol, and then another note A or la, and then another note B or C, and another note C4 or do. So in other words, these are the notes to be used. But I'll make it easier for us. So we will delete this. I'll teach you another easier way to do this. Well, let's cancel this complicated notes. Okay. And arrays, we will make it as easy as possible. So all you have to do is actually to declare the digital pin that you want to use. For example, we will be using digital pin 8 or number 8 in our program. So what I'll do is I will be using digital 8 to produce the notes. So you will see here tone 8, and then there's a melody, this note, which represent the sound in the original program. But what I'll do, I'll just put tone, and then we will just put here the, for example, 1000. Okay, and then I will just put no tone, and I will just put here a delay. For example, tone 8 1000, I'll put a delay of 1000. That is 1 second delay. And then no tone, I'll put another delay of 1000. So if you run the code, there's an error because there's a bracket that I missed here. So let's stop. And let's cancel one bracket here. Let's cancel that bracket again. Start the simulation. See, you heard a tone which is good for 1 second, but it only does that for one time or one time only. So if you want to repeatedly make a sound of the tone that we have produced infinitely, so we can put this program not in setup but in the loop, inside the loop, so that when you run it, it will be making a sound, but it will never stop. It will make a sound for 1 second, and then no sound, and then sound again, no sound. So that's how easy it is to use this to make a program that will make a sound. Now, if you change the 10,000, you make it 500, and this one also you make it 500. When you start it, then the sound will be faster than the previous sound that you heard. Okay, and if you really want it to be very fast, then we can even make it 100 millisecond here, 100 millisecond here, and start it, and it will be like an alarm. That's the how simple it is to make a sound. Okay, and we can also change the frequency here. Instead of using 1000, we can make it, for example, 500, so that the sound will be lower pitched. So if you start it, look or listen, that's the effect. So by changing the number here, you will be able to increase or to make the sound higher or lower. For example, if I write 2000, that's the sound for 2000. Now, of course, if you have a knowledge in music, then there's a particular frequency for the notes. Let's say you know music, so the notes are do, re, mi, fa, sol, la, si, do, or C, D, E, F, G, A, B, C, and these notes has a particular frequency. But for those who don't know anything about music or notes or frequency for the notes, then this is enough. just to create an alarm. So these are some examples. Now this one we can save it for later or for future use. Let's click this and let's change this to buzzer example, or let's just say buzzer. And of course, when you go to the Tinkercad logo, when you click it, you may put some information through the settings here of your buzzer project properties, and then you give a description. This is a simple alarm sound project. It makes a sound every half second repeatedly. So this is what you can put in your description, and then make a tag, Arduino, sound, alarm, buzzer, and then in the privacy, you click on the public, yeah, keep it public, make it public in the privacy, public domain, and then save the changes. Now let's create another project where we will be making the sound, and at the same time, there will be an LED that is blinking. So we can do that over here in our buzzer program. We click it and we click on Tinker this, and then you will be able to edit the code. So let's put one LED. Let's say that the LED will be connected to the ground also, but maybe it's better if we put a breadboard for this. Okay, let's say we have a breadboard, and let's cancel the, or let's put the LED on E1 and E2. And then the E1, we connect it on the negative, and then let's make it black. And the negative, we connect also we remove this ground of the buzzer, and instead let's just put the negative on the negative row of the breadboard. And then the digital 8, we will put it there later. I'll just put this also on the breadboard on E8 and E13. So letter E number 8 is also connected to A8, B8, C8, and D8. So you can take one hole here, A8, and connect it to your digital pin for the ground, or for the ground. So I may put it here, but because we are using the breadboard, I'll just connect it on the negative of the breadboard here on the row for the negative. And for E number 13, which is the positive of the buzzer, we can just connect the letters A, B, C, D to the digital pin number 8. You can make it look nicer by clicking first here, and then click here. And we can also make it red to represent positive. Also here, we can make it red to represent I forgot the anode. So the anode is E2. So we can use A2, B2, C2, and we will connect this one to the pin number 13. Okay. Now, so our anode is connected to digital 13. Our cathode is connected to the ground. Our negative of the negative of the speaker or the buzzer is connected to the ground also, and the positive of the buzzer is connected directly to the digital 8. Take note that the ground of the Arduino is connected to the negative row of the breadboard. This is done so that you can use not just one hole for the ground, and then the 13 is connected not directly to the anode, but through the hole of A2, which is also connected to E2. and the digital 8 is not directly connected to positive or E13, but it's connected to E or A13. So A13 and E13 are also connected together. So this is familiarizing yourself with the breadboard. Now, when we run the program, of course, there will be nothing happening on the LED because it's not included yet in the program. So we stop it, go to the code, and let's try to put or do something here about our LED. So let's say I will put here digital right, and then I will write the number of the LED, which is number 13, and then I'll make it high or 1. And on the other side, no tone. After that, we will also put digital right, but this time we will turn off the LED. So if you haven't watched the video on how to blink the LED, you can watch it in one of the YouTube videos that I have uploaded. So this will be 0. So this time we are combining what we learned in blinking the LED and what we learned about the speaker or the buzzer. So when you simulate this or simulate it, and you start the simulation, it must be making a sound and at the same time, it's blinking the LED. Now let's stop the simulation and let's make the blink, the timer longer. Let's make it 1000 and the delay here also 1000. And I think the LED, we need to connect a resistor. So let's cancel this connection here. The our digital 13 wire, we delete this first. So let's maximize our screen. Code. This wire, delete. Okay, and let's put a resistor to our anode, and I connect that anode to a resistor. Let's make the resistance 100 ohms only so that it will be brighter. And let's rotate the resistor, rotate it. And let's connect one leg of the resistor to anode. This is on D2 and the other leg terminal 2 on D6. So from D6, I'll get a line and I'll connect it to our digital pin number 13. And then when we run the simulation or when we simulate it, there's an error on delay 1000. So let's put a close bracket, semicolon. Again, start the simulation. Still a delay because the bracket is expected. So let's put a bracket after this. Okay, let's close this. Let's put a bracket here. All right, enter, and then let's start the simulation. Now you can see the light is the light on the resistor on the LED here while this is blinking. We can also change the color of our LED. Let's make it green. Maybe this is better than the red. So that's it. Let's start the simulation. So that's it. It's now turning on and off. Okay, so you can use this for the alarm. For example, you made an intruder alarm system using a sensor. So that's it for now, and we will still continue with our other examples. And take note of this Arduino project example because this can be useful if you will be making use of a buzzer or an alert system with a sound. If, for example, there's a thief or an intruder in your homes. So that's it. I hope you subscribe to this channel, ercTipsKnowLogy, so that we can reach our goal of reaching 1,000 subscribers. Please like the video if you like it and share it with your friends so that the beginners of Arduino users can make also simple projects like this. Thank you so much.